a well-known personality. Whenever I had a chance to listen to him, he gives the impression that he is true authority on the subject. No matter what subject he has been asked to talk on. Being away from Pakistan for many, many years, whenever we come across and he comes here, he's always behaved. He's a son of the soil, a true Pakistani, a very down-to-earth person. In addition to what I'm just going to tell him about his academic activities, he's a professor of nephrology and academic director for Department of Clinical Nephrology and Transplantation at SPARS, National Health Service Trust, and William Harvey Research Institute at Queen Mary College, University of London. He's also director of Diabetic Kidney Center for East London and member of advisory board for VARS Life Sciences Center, Global Kidney Foundation, and joint national formulary for BNF. I think this is the briefest, very brief, as brief as it possibly could be. Otherwise, knowing him, what I know, his introduction, I think, would take more than 1 hour. So with a few words, let us all welcome Professor Magdi Yaqoob.
Sorry about the mix-up. This happens. So while they're setting it up, first of all, I would like to thank the PSN. I should thank them twice, because to go through the pain of organizing the same meeting twice, Pakistani. In some ways, I'm more Pakistani than you guys are, because you have got the benefit of breathing the air of this beloved country. We just tasted a few days and look forward to coming back to have that smell of air of our country every 1 or 2 years. So thank you for asking me to come again. The population of this country is 850 million. This is the 3rd most populous country in the world after China and India. So I would like you to roll your sleeves and get ready to deal with this epidemic of chronic kidney disease. You face challenges which I did not have when I was a trainee. We did not have the temptations of social media, and we were not caged by ever-growing guidelines and protocols. So you are facing a different set of challenges than what we had when we were training. When I was waking up in the morning, it occurred to me that what would I say to people who are so clever to inspire me? And one of the things which occurred to me is the data which has emerged recently, which astonished me, and I'm sure it will to you as well, that in a day, an adult makes 30,000 to 35,000 decisions every day. 30 to 35,000 decisions we make every day. I bet you if you ask you how many decisions you remember you took, you could tell me 2 or 3. Because 99.8% of the decisions we take are subconscious thinking. We don't even think about it. Only 0.2% requires subconscious thinking. Can you imagine a cyborg sitting next to you who can take care of this subconscious decision making? 99.8%. He is ready. So the difference between you in future and a cyborg is 0.2%. That is the challenge. As a trainee, I'm sad to say that even that 0.2% thinking has been reduced to 0.01% thinking, because you are all in autopilot jobs. You don't even think when you examine the patient. It just happens. Compassion is gone. You've become a robot. And if that is going to be how you're going to be, then cyborg will replace you. People are working at that. So please, my advice to you is to make that gap from 0.2% to as big as possible. Because it's a conscious thinking which a cyborg can never take over. Remember that. Second thing which I'll ask you, if you get a chance, to read the biography of an American president. Yes, not the current one. An American president. His name was Benjamin Franklin. He was a polymath. He knew about everything. He was the forefather, the founding forefather of America. He was a physicist, he was a theologian, he was an orator, just name it, historian. And he had a quote, which I'll say. He said once, "Tell me, I will forget. Teach me, I may remember. Involve me, I will learn." I've added 2 more lines to this quotation. Tell me a story, I will remember. Trust me, I will deliver. So I'm requesting all the faculty sitting in the front row to trust all the juniors in the room. I bet you they will deliver. They're ready to deliver. And as I said, that if I tell you a story, you will remember. So you're starting and embarking on your career, and I'll tell you a true story before I start my subject, which some of you may find boring. The story is a true story. It's 1920. The Prime Minister of the United Kingdom is invited as a chief guest to a medical graduation ceremony. Yes, the Prime Minister of the United Kingdom in 1920 did attend those ceremonies, rather than the current lot who are preoccupied with Brexit discussions. So the Dean, who was introducing the Prime Minister, made a little speech and gave few word of wisdom to his new medical doctors who are about to start the journey by telling his own story. And he said to his medical students that when he qualified as a young doctor, one day he was sitting in his room. Remember, it's 1920, there was no NHS. In United Kingdom, before NHS, for doctor services, patients had to pay. It was exactly the same as any other country. Now NHS means free at source. So he heard a knock on his door. It was a stormy night, and an old woman, very, very worried, requested him that can he come and see a son of his, the only son, who is very ill. This dean, who used to be a young doctor, went with her, attended to the son, and he found that they were living in abject poverty. He did what he did, and she gave him a bag with some money in it. So he refused to take it by looking at the social circumstances of that family and said, "No, you don't worry about it. I can't take this money from you. But I assure you that I will keep looking after your son." So he's telling the story to the medical students and his graduates. And I'm telling you this to the trainees who are going to be consultants soon, that this is a doctor. Doctor is a profession which is closest to mercy and closest to God. So you are honored to be what you are. When he finished his talk, the Prime Minister stood up and he kissed the hand of the Dean. And he said that, "Oh God, I have been looking for you. That little boy you saved is me." He was Lloyd George, the Prime Minister of the United Kingdom in 1920. Can you imagine when you go on Monday and see a patient and unearth a little story in him, you might be touching the life of somebody great in future. So after saying these few sentences, I'll start with the subject, which is the topic today. We talk about ischemic perfusion injury. Most of you would have heard this. And I think it is a big problem. How it impacts the nephrology in the sense of acute kidney injury. This is our own data. That we looked at 5,000 patients who underwent coronary artery bypass surgery. And those who developed acute kidney injury, this was transient, there were not even dialysis required, very mild kidney injury as compared to those who did not. When they were properly matched, those who had acute kidney injury, despite having the same characteristic, they had high mortality. So acute kidney injury, post-coronary artery bypass surgery, almost certainly due to ischemic perfusion injury, is associated with increased mortality. More startling is the data from Sweden, that they have got a myocardial infarction registry. Every person who gets myocardial infarction in Sweden gets into a registry. It's now 50,000 patients in that registry, and they divided that patients according to the stages of CKD and looked at the mortality a year out after MI by looking at the different stages of CKD. If you had stage 5 chronic kidney disease and you get an MI, the survival of that group at 1 year was 40%, 60% were dead. This is ischemic perfusion injury, by the way. The worst outcome in cancer are of pancreatic cancer at the moment. We haven't yet touched. And the 1 year survival of pancreatic cancer is 40%. So MI in stage 5 chronic kidney disease, survival 40%. But those who do transplants, particularly those in the countries where we do a lot of disease kidney transplants, unlike live kidney, the biggest problem for us now is delayed graft function rather than acute rejections. We have conquered rejections. And delayed graft function is ischemic perfusion injury. How does that delayed graft function affect the graft? In the initial part, we didn't even know how to define delayed graft, but then we agreed to a definition that anyone who requires 1 session of dialysis within the 7 days post-transplant is called delayed graft function. Using that definition, we realized that it is associated with increased hospital stay, increased risk of rejections, and inferior graft outcomes and inferior graft function. Out of 952 citations, we selected 33 studies and did a meta-analysis to ask these questions. And it was found that there was 41% increased risk of graft loss if your graft had a delayed graft function. Just 1 dialysis session post-transplant. 46% increased risk of rejection. and 66% increased risk of inferior graft function. In our own center, one of my PhD students from Tokyo, Japan, yes, I'm glad to report that people from Japan come to do PhD with me. So we are doing very well. In his PhD, as an initial, we asked him to look at this, and we defined delayed graft function slightly differently. Because dialysis is just too advanced, in my opinion. So he said that can we have delayed graft function, which is non-dialysis requiring and dialysis requiring. And the non-dialysis requiring was defined as fall of creatinine less than 30% second day post-transplant. And even those who, if you look at it, that the graft function was inferior at 1 year, even though they did not require, the slow graft function is also bad news, and that affects a lot of liver-related transplants. So it is relevant for those who do liver-related transplants. We and others have done a lot of studies how to prevent delayed graft function, and we have had very, very modest successes. The most interesting thing is how to modulate the donor, whether it's a live donor or it is a deceased donor. Can we change the donor because the kidney is coming from that donor? And it is a huge ethical issue. Can you imagine that first to take a permission to get a kidney from somebody and then also tell the family that I'm going to randomize your loved one who is being a donor into one to another arm, which is a huge challenge. But people have done it. So now I come to what else we can do. That is there any way we can beat ischemia reperfusion injury by its own taste, that is by doing ischemia. And this was a very landmark study done by Charles Murray in 1986. Got published in a very low-key journal. And 5 animals only, they were dogs. And this is a standard way which we do it all the time in our lab. We just ligate the left and anterior descending artery, expose the heart, and then looked at the size of the myocardial infarction. And they did that, and this was around about 30% of the anterior myocardial was infarcted. But they did this. But before that, they did brief periods of ischemia and reperfusion. And then they did the ligation. The size of the infarct was much, much lower. And that was, in my opinion, the seminal paper. And nobody paid a joint of an attention to this piece of work. It took 17 years for somebody to do the same work but in a different way, to prove the cardiologist that what they are doing with PCI is in fact doing post-reperfusion, ischemia reperfusion. When the catheter is there and they are injecting whatever they are doing, they are interrupting the circulation for a short period of time. So it is also ischemia reperfusion of short burst in the reperfusion phase. And they mimicked that, and they found that if they did that, there was a significant improvement as well. The landmark paper, in my opinion, came here. That somebody thought of it, that if we were to do ischemia away from heart, if I do it in the thigh or in the arm, 5 minutes of ischemia, reperfusion, 3 cycles, doesn't do any injury to your arm. And then myocardial infarction, will it shorten the size of the myocardial infarction? And that's what did happen as well. We and others have now gone through the whole signaling which happens intracellularly. So the first question was that can we do myocardial infarction in uremic rats? It's a huge challenge. It's a huge challenge. And we created that model in our lab and asked the question that would the size of myocardial infarction be bigger in uremic animals as compared to non-uremic animals? Same injury, everything the same. And that's what we found. If you look at it, area at risk was the same, LAD was ligated, but the size of the infarct in the urine mechanism was much bigger as compared to. So it partly explained the data which I alluded to earlier, but this is another piece of data published in New England Journals by Charlie Herzog, that overall mortality in dialysis patients after MI at 2 years is 80%. So part of that could be because our urine myocardium, when it gets the myocardial infarction, is quite bigger. And with that comes the potential problems. Can we prevent that? Can we prevent the size of myocardial infarction? So the second question we asked was, can the uremic heart respond to ischemic preconditioning, like what Charles Murray did 20 years ago, but he used normal animals? Can we do the same in uremic animals? We know that most of the strategies which work in normal people don't work in uremic patients. So the first question was to prove to ourselves that uremic heart is not resistant to this ischemic preconditioning. And would the threshold of preconditioning be different? Because we and others have seen that in diabetic heart, when you do ischemic preconditioning, they are partially resistant to ischemic preconditioning. You need 4 cycles to get the same response as compared to non-diabetic. And that is the data. So we did this, and this is the uremic heart. There are 5-6 nephrectomy, control, no preconditioning, 60% of the heart had gone. Reduced to 5% if you had done preconditioning. I have been in the game for the last 25 years doing this sort of work. I have never seen any drug in that level of protection. It was mind-blowing, never been seen before. And more good was that even one cycle, so 5 minutes ischemic in the arm or the thigh of the animal, you still saw the same protection. It was just unbelievable. I just could not believe it. And I told my PhD student to repeat it 3 times before I believed it. Because up till that time I have been 10% or 5% difference. It was just mind-blowing. So now we are coming to the remote, because this is now, nobody will allow me to do ischemic preparation to the heart. I want to bring it to the clinic. I want to prove it that doing it remote in the arm would be the same. So we did the preconditioning in the thigh, and we did the LAD ligation, and we saw the same benefit. Exactly the same benefit. In fact, slightly better than uremic hearts. So it was exciting. We were seriously excited. We got the whole signaling sorted and got it published. ICU came in a cardiology journal. So that let's show it to the cardiologist that we nephrologists can do better at your research than ours. And we got the editorial from the top guns in the field who said, "Hooray! You have cracked the problems." And I got a personal letter from the editor saying, "You need to now do a randomized controlled trials. You've done the basic science, now bring it to the bedside." That is the excitement. There is no pill involved. It's just a blood pressure cuff. I don't need to go to MHRA to get the permission to do the intervention. I just need a local ethics committee. We did that. And which patient to study? Either as wait for an ethics to get for the deceased donor, because that's what I wanted to do. I wanted to do deceased donor, which was the subject, organ preservation, delayed graft function. Or we do the same, which I said initially, that coronary artery bypass surgery, we have the biggest cardiac unit in the world, can look at acute kidney injury post-CABG in high-risk patients. and do this strategy, preconditioning and non-preconditioning, before they go for the operating table. Before we were doing this, we had to prove that it also prevents acute kidney injury, and it did in the animal models. It did the same benefit in acute kidney injury. You do ischemia reperfusion remote, and then do ischemia injury to the kidney, and they were protected. So double whammy, isn't it? Wonderful. So we did this study. Sean Gallagher, the first author, believe it or not, is a cardiologist. Yes, cardiologists come and do PhD in my lab, in a renal lab. And we did this single center study where, before we did this, we wanted to show that this is an issue to power our study. And we found that AKI is a problem, and AKI is associated with worse outcome post-CABG. So we designed a randomized controlled double-blind study, sham versus proper ischemia reperfusion, powered based on our own data and our experimental data. And that was the result. P-value of 1, no difference whatsoever. So I show you that in the rat, I'd never seen the data like that before. When it came to human beings, proper breathing human beings, when we did a proper randomized control study, there was no difference in incidence of acute kidney injury. We looked at every biomarker you can think of, no difference. We looked at myocardial injury biomarkers, no difference. And the p-value of 1, so I can say negative study, no difference. 12 months later, we had published our studies, our hands were, we said maybe it doesn't work in humans. Things work in rats, they don't work in humans. And we had written an editorial why that would be the case. A study came from Germany, and they did exactly the same study as us. And they said that yes, they found benefit. It's the same study. Published the data in JAMA, so now you've got one negative and one positive study. So a scientist within me was saying, I wish the Germans are right and we got it wrong in our study. And as a clinician, I was saying, I hope they're bloody wrong. They didn't know how to do the study. So we had to wait, and we knew there would be 2 multi-center studies breaking very shortly. And in one study, we were participating as well as one of the centers. And this is the study which got published in New England Journal of Medicine, done by Derek Adams' group from UCL, who are our next door neighbors in London. Very big study, multi-center, 800 patients in each study, coronary artery bypass surgery. Primary endpoint was there because they're cardiologists, they wanted to look at the heart protection. And second endpoint was kidney outcomes, similar to our study. Believe me, I've never waited for some study with so much keenness as this study, because I wanted to see whether we got it wrong or the Germans got it wrong. So, first page says there was no difference in the cardiac endpoint, which ours was secondary endpoint, which was negative. Their second endpoint was kidneys, ours was primary endpoint kidneys. Look at the p-value, 0.98, ours was 1. No difference whatsoever. That's it, that was not enough. There was another study, same issue, the second paper, in New England Journal of Medicine from America. 600 patients in each one, same study, but done in America. Same protocol as ours, no difference. And they also found no difference whatsoever. So, we got it right. But ours was a single center study, there were multi-center studies. So why was the case? Why? What was the difference between Germany and the other three states? Because you never stop. This is the main thing in science. You need to keep asking questions. Where did we go wrong? And that was the difference. That all the patients in our and the other studies were anesthetized with isoflurane. And in Germany, they were using propofol. If you use isoflurane, the preconditioning benefits disappear. Because isoflurane is a chemical way of doing exactly the same signaling as preconditioning does. Propofol does not do that. So that was the difference. But I think the difference was bigger. That rats are rats, mice are mice, humans are like this. They are diabetic, they are on drugs which interfere with preconditioning, or the signaling which is activated by preconditioning. CKD, we know that in its own right does not cause any harm to the, or it does not prevent preconditioning. Cholesterol does. Certain medications do obesity and senescence. The senescence is a huge issue which we are tackling at the moment. So human is, because lab animals are bred for me especially. They are completely clean. So what we demonstrate in rats cannot be generalizable to a common population. But 99% of the drugs are discovered in a rat. That's why when the drug comes to the bedside, there is a 99% failure rate. That's why a pharma company, it costs them £1 billion for a drug to come to the bed, because they have 99 failures and 1 success. So we learned the hard way. But let's see, it was all anesthesia. Looking at a group where there is no anesthetic involved, and the other study which we wanted to do was myocardial infarction. Patient comes with myocardial infarction in a Western country, is brought within 90 minutes. You get chest pain, paramedic will take you to the cath lab within 90 minutes. That is the timing. So they did a randomized control trial of all patients with established MI going for PCI. Half got preconditioning and half didn't, and looked at the myocardial infarction size. And in that setting, unlike rats, they did not find any significant difference. So preconditioning did not work. Is there any place for it? Is there any place for it? The biggest problem for me as a scientist that we don't know by any biochemical means that when I've done preconditioning, who got preconditioned? Like it's not like a blood pressure, I gave a pill and say whether the blood pressure went down or not. I'm doing an intervention, but I don't know whether that person got preconditioned or not. We don't have those biochemical methods. In many surgical procedures now, they do cooling of the blood, and cooling is in fact another way of preconditioning. There's some data also from our lab, which is contrast-induced nephropathy. I have come to the conclusion that there is nothing. Contrast-induced nephropathy doesn't exist. There is no contrast-induced nephropathy. You've heard it from me. I've worked on this bloody thing for 30 years. I've come to the conclusion there is nothing called contrast-induced nephropathy. It's a biochemical artifact. Transplantation. Yes, that is the best thing if you wanted to do. The delayed function rate was 50-fold less as compared to those who did not. So, preconditioning, how we do it, possibly hypothermia is the future. And 1 degree fall in your temperature does not do any harm at all. Many of the nephrologists who come from USA and UK, they always lower the dialysis temperature anyway to prevent intradialytic hypotension. Many of us do it. So if you get intradialytic hypotension, you can reduce the temperature of the dialysis which prevents them. That's the degree of we are talking about. So I would recommend that you do a lot of light loaders. You can do the same study in light loaders. Randomized controlled trial of rider should be a countrywide. And if you want a New England Journal of Medicine paper, that will get you there. Because there's no desire to do that in the West. Live donors, 1 degree less temperature, hypothermia versus no, and look at delayed graft function. You need many patients because the delayed graft function is so low. You do not like slow graft function, but mainly graft function at 1 year. And I bet you see marked improvement in graft function at 1 year in preconditioning. SIUT will do it 300 or 350 live donors in a year. With the center like you and few others, you can do the study within a year. And believe me, if you are looking for a New England medicine